The Proton launch vehicle weighs over 705 metric tons, or more than 1.5 million pounds at launch, and this is 191 feet tall, which is about the height of a 19-story building. But just exactly how fast can it go? Here's a speed comparison that will help put it into perspective. Velocity is the distance per unit time that an object travels in a specified direction. We all know the ILS Proton moves at incredible speeds. That's a given. But just how fast is a Proton rocket exactly? At liftoff plus 38 seconds, here's the formula for the answer. 567 miles per hour equals 253 meters per second. Using this formula, the Proton closely matches the velocity of several of the world's fastest commercial jetliners at cruising speed. At liftoff plus 68 seconds, here's how fast the ILS Proton is moving. Mach 2, or twice the speed of sound. At this point in the mission, the Proton matches the velocity of an F-22 Raptor with full afterburners engaged. Finally, at liftoff plus 82 seconds, the ILS Proton is traveling at Mach 3, or 3 times the speed of sound. At this point in the mission, the Proton matches the velocity of an SR-71 Blackbird U.S. reconnaissance jet. We'll leave you with this staggering thought about the velocity of an ILS Proton rocket. At maximum velocity, the Proton travels at 5.9 miles per second. At that velocity, the Proton can travel from San Francisco, California, on the United States West Coast, to New York, New York, on the United States East Coast, in 7.3 minutes.
This flight, designed for the Astra 2G satellite, is a 5-burn BREEZE-M mission and will take 9 hours and 12 minutes from liftoff to satellite separation into the satellite into the planned geostationary transfer orbit. Let's take a look at the Astra 2G mission profile.
The following is a description of the Geosynchronous Transfer Orbit, or GTO, mission flight profile of the ILS Proton launch vehicle with the Astra 2G communications satellite on board. The first 3 stages of the Proton function to propel the orbital unit into a suborbital trajectory. The orbital unit consists of the BREEZE-M, payload adapter system, and the Astra 2G satellite. The sequence starts with the ignition of the powerful first stage engines that output 2.4 million pounds of thrust at sea level. As the ILS Proton lifts off from its launch pad, it immediately executes a roll maneuver to align its flight launch azimuth to 61.3 degrees in order to achieve a parking orbit inclination of 51.5 degrees. As it travels in an east-northeast direction across Kazakhstan towards the Pacific Ocean. The engines fire for about 2 minutes, during which time the ILS Proton experiences maximum dynamic pressure. Then the first stage separation occurs. The second stage engine follows with nearly 540,000 pounds of thrust for 3.5 minutes. And then the third stage engine fires with 131,000 pounds of thrust for 4 minutes. The payload fairing is separated soon after the third stage ignition high above the Earth's dense atmosphere. At stage 3 separation, the orbital unit has traveled from Baikonur to Russia near the eastern edge of Kazakhstan at 51.5 degrees north latitude and is moving about 7,300 meters per second, or 4.5 miles per second. The upper stage of the ILS Proton rocket is called the BREEZE-M and is designed to inject payloads into a wide variety of target orbits. There are 5 BREEZE-M burns in this GTO mission design. The first BREEZE-M burn occurs about 2 minutes after the third stage separation, when the orbital unit is still in a suborbital trajectory. This will last long enough to achieve a low Earth circular parking orbit of 175 kilometers. This 4.5-minute burn spans from Siberia to Russia's east coast. About 1 orbital revolution later, the second BREEZE-M burn for the Astra 2G mission occurs about 52 minutes after the first burn main engine cutoff. The resulting elliptical orbit is called the intermediate orbit and increases the apogee to 5,000 kilometers, the perigee to 270 kilometers, and decreases the inclination to 50.3 degrees. This 17.7-minute burn spans from the South Atlantic, 800 miles east of Rio de Janeiro, to Libya in North Africa. 2 hours, 3 minutes after the second burn, the third BRIZEM burn starts. Soon after this burn completes, the depleted auxiliary propellant tank, or APT, is jettisoned, and the fourth BRIZEM burn begins. The resulting orbit is called the transfer orbit, where apogee is greatly increased to 35,757 kilometers, closely matching the geosynchronous altitude, making the orbit more elliptical and maintaining the equatorial plane perigee location. Both burns add up to approximately 17.5 minutes and span from South Pacific, 200 miles west of Santiago, Chile, to 300 miles west of Morocco. During the coast phases between main engine burns, the BRIZEM performs various attitude maneuvers in order for the Astra 2G spacecraft to be exposed to the sun at predetermined solar illumination angles, which is designed to satisfy its thermal and power requirements. About 5 hours later, during the fifth and final BRIZEM burn, the orbital unit will perform a large plane change maneuver from 49.1 degrees to 23 degrees inclination, slightly decreasing its apogee to 35,736 kilometers while increasing its perigee to 4,163 kilometers in a 9-minute, 8-second burn. The fifth BRIZEM burn and spacecraft separation occur high above the Indian Ocean. About 12.5 minutes after MECO, the Astra 2G satellite is separated from the BRIZEM to reach its targeted orbit. The total mission time from launch to Astra 2G spacecraft separation is approximately 9 hours and 12 minutes.
All right, we're at just under T-minus 8 minutes for the mission. Once the Astra 2G satellite completes the in-orbit testing period, Astra 2G will provide replacement as well as incremental satellite capacity from the 28.2 to 28.5 degrees east orbital slot. The different beams provide coverage over the United Kingdom, Ireland, Europe, and West Africa.
The first burn of the BRIZEM upper stage is scheduled for completion about 16 minutes into the flight, and our live coverage will conclude after that burn since the rocket will be out of range of our tracking stations as planned. You can stay up to date on the key mission milestones by visiting the ILS website, which is ilslaunch.com, by following us on Twitter, and by liking us on Facebook. Astra 2G could be used to host SatMed, an e-health platform conceived by SES and supported by the Luxembourg government and the Ministry of Cooperation and Humanitarian Action. SatMed is a satellite-based communication solution aimed to improve public health in emerging and developing countries, most significantly in isolated areas with poor connectivity. SatMed enables communication between doctors, thus allowing the transfer and exchange of medical knowledge and supporting tools for medical e-learning and e-teaching. An IT cloud infrastructure accessible around the globe facilitates the data exchange between professionals and the setup of a medical infrastructure, such as electronic medical records and teleradiology systems. SatMed is an open, flexible, and affordable solution that perfectly fits SES's range of satellite-based e-activities.
We're about T-minus 6.5 minutes. This mission requires many working on the launch campaign to observe their holiday season away from their family and friends. Here you will see some pictures from the Astra 2G mission that depicts some of these special events over the years. I would like to wish everyone working on the mission in Baikonur a sincere happy holidays and thank you for your personal sacrifices for this mission. While not being the same as being at home, the teams at the launch site make a concerted effort to remember birthdays, holidays, and other observances. When in Baikonur during a birthday or a holiday, those assigned to the campaign give their best effort to include everyone and make the best of things by passing the time in a fun, festive environment.
Just before we get to liftoff, here are some beautiful images of the Astra 2G satellite in production and testing at Airbus. All right, and now my colleague TC will take us through the final pre-launch preparations and through liftoff of Astra 2G. TC?
Is everyone getting excited with anticipation of this launch? Preparations for today's mission started about 3 years ago with the building of the satellite and the mission integration and planning for launch on this ILS Proton. Mission teams are in their places in the launch bunker, control rooms, ground stations, and communication centers around the world. The final go for launch, polling we mentioned earlier, is being completed now.
And I wanted to add for our viewers that as the ILS Proton travels easterly downrange, you may notice some very brief delays in our reporting of key mission milestones. The reason behind this delay is that as the vehicle follows its path, it will pass out of range of the Baikonur receiving stations. At this point, signals are received by stations downrange and then transmitted back to Baikonur.
Will do. We're coming up on T-minus 2 minutes. The weather's looking really good, clear night. We should have a beautiful view of this launch and those there in Baikonur to watch it. In addition to those at the Baikonur Cosmodrome, there are many others watching who have played an important role in the Astra 2G mission, and we'd like to say thanks for all your hard work in getting to this moment. SES employees in Luxembourg and their regional offices around the world, we'd like to take a moment to say hello to SES VIP Martin Hallowell, who made the lengthy journey to Baikonur and is watching live from the Cosmodrome. Airbus Defense and Space employees in Europe, sites, and around the world, Khrushchev employees in Moscow and other regions of Russia, ILS headquarters in Reston, Virginia, and many others who have helped today's launch of Astra 2G a reality. We're coming up on T-minus 1 minute to launch in 7 seconds. T-minus 1 minute. You can hear some of the ambiance from the Cosmodrome. We'll also be hearing the Russian announcer giving the instructions and the information as the broadcast comes down to countdown here. As I said earlier, it's about minus 3 to 5 degrees with a little bit of a wind, so it's a little chilly out there watching the launch tonight. Just under 30 seconds to launch. Now we're going to step aside for the launch of Astra 2G.
15, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
We have ignition. We have liftoff of an ILS Proton from the Baikonur Cosmodrome in Kazakhstan with the Astra 2G satellite on board. About 10 seconds after liftoff, the vehicle does a roll maneuver to alter the attitude of the vertically launched Proton towards the northeasterly flight plan, and will soon experience maximum Q, which is the maximum dynamic pressure, which is when the aerodynamic stress on the launch vehicle in atmospheric flight is maximized. For Proton, max Q occurs about 1 minute and 2 seconds after liftoff and at a velocity of Mach 1.6. There it goes. Everything seems to be proceeding nominally as the vehicle ascends over the Cosmodrome in a northeasterly direction with a flight azimuth of approximately 61.3 degrees. We're coming up on the first stage separation from the second stage that is set to occur at 2 minutes into the flight. On clear nights, observers at the Baikonur Cosmodrome will see a halo effect of light as the second stage engines ignite prior to the separation from the first stage. Look at it going. Wow, that looks beautiful. Actually, you can see a halo on the screen too, or at least I'm seeing one. But this is not what I'm talking about earlier. Judy's reporting nominally from Baikonur from our Mission Control Center, and here we go. And we have confirmation of ignition of the second stage and a good separation from the first stage. Beautiful camera work from Baikonur.